We know how to make a Q, so we do a 3. We put the multiplication into the stack. We have parentheses. Remember, we put that into the Q. We have another parentheses. We put that into the Q. We have 4, which is a number, so we put that into the deck. We have a plus sign. We treat this like it's an empty stack. So we put the plus sign up. We got the 5. We put it into the deck. We reach the closed parentheses. Remember, that just means to empty out the stack until we reach the next open parentheses. Okay, now we got the modulus. Excuse me, we got the modulus that goes inside the stack. We reach another closed parentheses, which means we empty this, we pop the stack until it gets to the next open parentheses.
I didn't copy his program, delayed this up. He said, this is too good for my class, so we need to do this.
I did something wrong just now.
Keep going.
Huh? George, I'm going to go.
Keep going.
George looked for every program online. He was just...
Now we got the
That was
C.
George, yo. That shit was funny.
We got a minus, but remember the precedence order, so we can't put the minus there. We gotta pop that, put it into the deck. Now we can put the minus in the stack. We got the 7, which goes into the deck. We got the division, which is 5. We go on top of the minus, and then we got our 8. So this is our postfix, right? Just remember that. This is our postfix.
Exactly, bro. Can you do that?
And what I was saying was, I don't empty my stack into the deck when I'm done. Like, this is what I use to make my tree, with 2 operators in the stack and the rest in the deck. This is what I use to operate my tree, right? So the rule is, once you start taking because all these is characters. These are characters and these are characters. Once you start taking these characters out the deck, they become nodes. In the stack, they become nodes. So you start with the top of the stack first, which is the division sign. So division sign, this, me putting a circle around it makes it a node. So this is the division sign, and the rule is you remove back. Hold on. This is just so we remember what was there. This is just so we remember what was there. So you pop this. Once you pop the stack, you remove back. Because remember, the difference between a queue and a deck is that you can go in either way. Remember, with a queue, we went in through the front. So now we're going in through the back. So we remove back, and that becomes the right. That becomes the right of our operator. This becomes the root. I have initialized to this is the root. So you remove back again. That goes to the left. That goes to the left of our operator. Now, right now, this is all that we have for a tree. So once keep in mind that these are 2 numbers. This is a 7, and this is an 8. Those are 2 numbers. We take this, and this becomes a reference in the deck. This becomes a reference in the deck. So this is all we have for a tree right now. This becomes a reference in the deck, and this is pulled out of the stack, right? So now we have another operator in the stack, which is a minus sign. The minus sign, you do the same thing. Make a minus sign. Remember, we put the reference back into the deck. And then we have a multiplication sign. Remember, the rule is you insert back right. So the right of this minus sign is going to be the reference to the division. The reference to the division is the right of this minus sign. Because remember, the rule is right, left, right? So we use this. Use this. Now we have the multiplication sign, which goes to the left of this minus sign. Sorry, make that bigger for you.
Bro, that's a $200.
The
Now that's over here.
reference was before that multiplication, right?
What'd you say?
The reference of the whole node was before the multiplication, right?
No, it never got back
I mean,
because
it was after the multiplication. It was Was the multiplication then the reference
Mm-mm.
that you circled?
Oh yeah. It was a multiplication, and then it was a division reference.
Yes.
Yep. So we just pulled a operator out of the deck, and there's another rule. So for each operator that you pull out of a stack or a deck, you're going to do left, right to that node. So when we pulled the division, we remove back right, then we remove back left. We pulled out another operator, then remove back right, remove back left. We just pulled a node, we just pulled an operator out of the deck. So now we start back from the deck and remove back right again. That's fine. It's supposed to be marked instead of plus. I don't know why.
Some other like alternative.
It's supposed to be 6 in modulus. It's supposed to be 6 in modulus. I forgot. I don't know what I did wrong, but it's supposed to be 6 in modulus. So we have an operator. The operator goes on the right. Right? Like I said, once you reach your operator, you remove back and then put it to the right. So we just got a modulus, right? But the modulus is also an operator. So we do it again. We start again, remove back, and then go to the right, which is 6. You have 6, right? So now we do 6 was a number, so we can go and do the left, which is a plus sign. The plus sign becomes the left of the modulus. The plus sign is an operator, right? So that means we go left again. We go right again. Go right to the plus sign and right to 5. Then we go left. Because it's a number, right? It's a number, so we just keep going. It's a number. Right?
Yeah,
You're going to kill me, but by default, this 3 goes here. I have no clue why. It just works. And I have not figured out that part. But I tried it in all the other equations, and I don't know how to write in code that the 3 goes back to here. I think it's because I have no clue how to write in code that the 3 goes back to here. But this is supposed to be our tree. I'm almost sure you can't see that. It's my tree.